This webinar is for you. This webinar is all about how you can help NASA, but also how NASA can help you. And so we want to make sure we are fulfilling that promise. So if there are any questions about those types of things or what NASA can do for you, please share. You are going to hear from a lot of experts today. We have a bunch of guest speakers, 7 of which. We'll hear from Mark Kushner, who is the Citizen Science Officer of NASA's Science Mission Directorate, and we'll hear about what NASA Citizen Science is. We're also going to hear from a NASA citizen scientist, Danny Roylance, who is also a veteran of the U.S. military. And along with Danny, we'll also hear from Kim Ferrante, who is the Community Engagement and Partnership Coordinator at the Veterans Affairs of Providence Healthcare System. And she'll talk to us about, along with Danny, talk to us about the benefits of citizen science. You're also going to hear from 2 project leaders. So if you're ready today to do some projects, we're going to do them together. Amy, who is going to be talking about Burst Chaser, and Carson Foles, who's going to talk about Daily Minor Planet. So look forward to both of those things. Because there are so many projects with NASA Citizen Science, we also have Sarah Kern with us to share a portfolio of all those. And then lastly, Clarence, who is going to share a lot of the resources that come out of NASA to help you gain a better understanding of what NASA can do for you as well. So if you have any questions leading up to that, we'll be hearing from him at the end here. All right, last piece of business. We are using a program called Mentimeter in order to do this presentation. So we want to be able to interact with you a lot. And so what that means is that you can actually respond to polls using a system of anonymous polling. And so when I turn the screen here, you'll see an example that we can test with. But there are 3 ways that you can join. One of which is an access code, which we'll be able to drop in the chat for you. And then, one of which that's in the chat for you, and I'm going to do that right now for you. And then another option is you can use this QR code that's going to show up for you momentarily when I switch the screen. Oh, just kidding, it's on the screen now. And then you can also add the code at the top if you just want to go to menti.com and use that code. You're welcome to do that as well. Now these options, 2 of them, one in the chat and one as a QR code, are going to stay visible. So you are able to test out the next question. So which of the following best describes you? How do you answer this question? You can answer with as many answers as you would like. If multiple apply to you, feel free to write them in, or to tap on those ones too. Let me add that QR code back. I think it disappeared. My bad. There you go. One moment. There we go. If you want to use the QR code, you can use that. And then that link in the chat will still get you to the right spot. All right, we've got U.S. military veterans. We've got active service, U.S.-based. You got one that's invisible from my end. 27% of you are other. I have friends in the military, about 7%, and that's changing. I'm going to give you another 20 seconds, and then I'm going to drop the QR code so we can also see the other question there. Awesome. Now we're doing so well. Perfect. I think we understand how to use Menti. That's great. Good. All right, I'm dropping the QR code. All right, and we also have military family. And about 22% of you are from that community as well. Cool. All right, great. Now I have another question for you. This one will disappear in a moment here. I'll give you 5 seconds. 5, 4, 3, 2, 1. Okay. All right. And then second question, for those of you who are in active service, excuse me, are you by chance stationed in a remote area? Another test question. Awesome. Oh, okay. Thank you, Pamela. Sorry. We'll try again here. If any of you are having trouble with the Mentimeter, of course, now my Wi-Fi snaps. Let's find out. If you're having trouble with the Menti, I'm going to drop the link in the chat again so you can access it. It might be because we have too many of you folks on. That's pretty impressive. That's pretty. There we go. Okay. There we go. All right. It's working again. Hopefully we can get those working. Let me get that QR code up for you again. All right. Awesome. All right. I'm going to move us forward since not all of us were in the active service stuff. Okay. I think it was just because there were so many people on there. Amazing. All right. Thanks, guys. All right. Moving forward. So I'm going to go ahead and introduce Mark Kushner to join us to talk about what NASA Citizen Science is. So go ahead, Mark, take it over.
Thanks so much, Emma. I am just super honored and humbled to be with you tonight. Thank you for your service. Thank you for spending time with us tonight. I just got to give a shout out to some friends I see. Ricky Greenfield, Pamela and Walter Lewis, Solar System Ambassadors. I see Michelle Moore in the house. Great to see you all. So next slide, please. So what is citizen science? So it's more fun to do science when you do it with other people. So we at NASA, we're using all of the modern collaboration tools we have access to share the process of doing science with anybody who'd like to do it with us. And we find that it's a way of not just having more fun and having more deep scientific experiences together, but there are also unique projects that we can do that we can't do any other way. So there are special scientific problems that we can really only get at with help from volunteers. So yeah, it's a global movement, and we're doing attacking all sorts of interesting problems. Um, so citizen scientists are helping NASA by observing. Sometimes you'll take a picture of something on your cell phone or your camera. Some people have their own telescopes in their backyard. Uh, some folks just live in particularly special places, and all they have to do to help us out is just go outside and answer a simple question like, is it raining or snowing? Right? Sometimes that's a huge help. And then other folks are looking at data. Oh my gosh, the amount of data that's coming down from satellites these days, it's enormous. And when you have 2 billion objects, for example, in a data set, you might give them to a computer and say, okay, computer, do your best. And it does 95% accurate job, and that still leaves 500,000 or millions of objects. The most interesting objects, in fact, are the ones that the computers couldn't get right. So we need help from humans. And that, just those steps there, taking data or analyzing data, that's just the beginning. The amazing stuff happens when we get together and we uh, allow people to do the special thing that humans do best, which is be curious. And we have so many curious and enterprising folks who have collaborated with us now through these projects that we've done some amazing things. Soon you're going to meet Carson Foles, who's going to tell you about his project searching for asteroids. Four his volunteers recently had asteroids named after them because they discovered them through this project. And you're also going to meet Danny Roylance and Amy Lean. Danny's story is absolutely incredible. I don't want to give it all away, but he's now a leader on a project. He went from a newbie to becoming a project team member, and he'll tell you all about that in a bit. I invite you all to try any of our projects. We have 31 active projects now at science.nasa.gov/citizen science. Don't just limit yourself to these two. There's something there for you, whatever your interests are. And next slide. And choose a project and do NASA science.
Before we jump to talking to Danny and Kim to talk about the benefits of citizen science, we want to know what volunteering opportunities mean for you. And so I'm going to go ahead and add that QR code back for you to answer this question on Menti again. And I'll go ahead and drop that link in the chat for you. There was a question in the chat related to this, asking about payment for participation. Everything we're talking about for NASA Citizen Science are unpaid volunteer opportunities, but we will talk a little bit about resources for veterans for job attainment and other things near the end of the call too. Mark, anything else to mention about that?
Yeah, we're going to talk about the Skill Bridge program. And of course, we're just, I just want to emphasize how much working together with people to do science has changed my life and has changed the lives of the people that I work with. I think you'll see that. And, give it a try. Come and go as you please.
Awesome. Looks like we have a lot of folks who want to exercise their minds and brains and learn a new skill. And let me tell you, all these will help you do that. They're great answers. Awesome. All right, I'm going to go ahead and move us forward. So if you haven't answered, it'll disappear for a while, but that's okay. Thank you all. All right. So we're going to bring up Danny and Kim to talk through the value of participating in citizen science and what they've experienced from it, Danny especially. And so I'm going to have them come up and chat a little bit about what this all means to both of them. So Kim, I'm going to pass it over to you.
Hi, everyone. I'm so stoked to be here today. My name is Kim Ferranti. I'm a social worker and one of the community engagement and partnership coordinators at the VA Providence Healthcare System in Rhode Island. And I see my friends from Rhode Island. So, hi. Hey, Mel. Um, just to let folks know, for those of you who are not enrolled in VHA healthcare, we provide a host of healthcare solutions from primary care to surgical to behavioral health to everything in between. So, if you are not enrolled in VHA healthcare system, I do encourage you to enroll. After this program, there will be a link to a VA locator near you. And we have them all over the United States. We have sites in Guam, Puerto Rico, really all across the world. There will be some sister stations there. So we really hope you can think about that. One of the things I want to talk about is what I do is I build relationships with individuals like SciStarter and NASA to optimize the health and well-being for our SMVF population, service member, family, and veteran population. Sadly, we know that suicide is higher in the SMVF population, and lack of purpose and lack of connection are drivers to suicide and behavioral health issues. And so what we want to do is we want to promote connectedness. We want to promote and enhance care transitions. And this program is doing just that. So you may ask, what do SciStarter, NASA, and VA, how do they relate? And I actually think it's a perfect marriage. You know, it's a confluence of science and soul. You know, this is an opportunity to come together and, you know, learn in the space, no pun intended, to enhance your skills, build community, and truly sort of use your creative flow, if you will, to kind of build on that sense of purpose. But we're going to hear a little bit more about that later. What I want to do is I want to welcome Army veteran Danny Roylance.
No, thanks, Kim. I guess to give you a little idea of my story is I joined the military from 1990 to 96 as a helicopter mechanic / crew chief, and did like, 10 days in Cambodia to missing in action and POW searches, and did disaster relief and medevac operations. So it was pretty active and it was nice. So I was first duty station was Hawaii, 4th to 25th Tropic Lightning and 58th Medevac. I liked it so much I did 2 tours there. You know, I didn't want to go home, but it was quite the experience. You know, when I left the military, I struggled with anxiety and intrusive thoughts, images, that were very unsettling. It gave me nightmares, and to where I was actually afraid to sleep and stuff. So I turned to alcohol to help me with that, and which is a really bad idea. But the I did go to the VA and ask for help, with the detoxing, and it took 7 times, but it worked. And I'm happy, very grateful to say I've got over 5 years of continuous sobriety now. And a big part of that is citizen science, and the therapy and things that the VA gave me. When I started, I heard about, citizen science from the news and stuff, but when I got involved with it, it was kind of a runoff from the VA, because I read about neuroplasticity, rewiring the brain so I don't go to the same thoughts, the same sort of actions and reactions and emotional triggers, have new ones, healthy ones. And so I started doing puzzles, just different things, to exercise my mind, because I really didn't want to go back to being a homeless veteran with my bottle of vodka. I just did. It was not an enjoyable experience, really. But as I was doing the puzzles and stuff, I did do. I'm now doing the greatest puzzle that I think the greatest puzzle in the universe, which is the universe. figuring out big mysteries that have been worked on for decades and decades. And that sense of what I was doing was important. It was needed, wanted, helpful. And some of the stuff actually helps our nation very well, helps our world, and diseases and things like that. It's very, very worthwhile. To continue service is kind of how I was looking at it. But let me see, I kind of lost track there. Oh yeah, my connection stuff that Kim was talking about. That was the important thing, because in the beginning of my sobriety, I was just hiking and taking pictures with my camera, and that was pretty much it. But the anxiety stayed and everything, so I needed more work, and I did some PTSD therapy later. But I got involved in the citizen science, and wow, that was some good rewiring, mapping, and connecting, because I could, where my thoughts were important, and needed and wanted from other people. And it was just neat to say, hey, I see this thing here. What about that? And some say, oh, that's neat. And you found a dipole, or you found this. Into like, oh, that's not entirely correct. What you see this when this happens. So you get education, and this education is coming from noted professors in their fields. I mean, talk about a free education, right? I mean, from some of the best in the world, actually. And that kind of stuff gives me a positive reason to wake up in the morning, something to wake up happy for and to look forward to. And like even when they're doing the Zoom calls, seeing if talking to friends and stuff like that, seeing how they're going. It's just the connection with other people that have the same thoughts and same interests that I do is really, really neat. That's pretty much it in a nutshell. Kind of a quick, high-speed view of it. I don't know if there's any other questions on that, or that's my introduction, I guess. So,
Danny, I really like how you framed that, and how when we know that connectivity and pro-social behaviors, like doing something for something bigger than yourself, can really contribute to like better health outcomes. So thank you for sharing that, and really kind of driving home the point that citizen scientists can really add value to yourself, not just as a sense of purpose, but also your health and well-being too. So thank you for that.
oh, you're very welcome. It's it's one of those things. It's a win-win. I get plenty out of it, and so does NASA, because that's a lot of information that needs to be looked at, big discoveries and things, and helping people with disease-borne, diseases from just mosquitoes and things like that. That's it's a big deal. So I'm happy, and I'm glad it's a win-win.
Hey, Danny, do I get to ask you a question or two?
Oh, you can ask all the questions you want, sir.
Hey, usually we hang out together on a science team call with our scientific colleagues. But I'll ask you the same questions I've asked you before, so everybody else can hear your cool story. So your first NASA project was Disc Detective, right?
Yes.
Yeah, how
That's
did you
the first one that looked to me, and it looked really neat. And wow, when I checked it out, it's a great project.
How did you learn about it?
A meteorologist on TV mentioned the Mars rover was needing some help for citizen science. I think it was picking pass or something. And I just thought it was something good for my kids, actually. And when I was looking it around, that's when I discovered Disc Detective and realized it's for everybody, not just kids, not just super scientists. And it I don't know, that Disc Detective is quite a I don't know, it's a Lamborghini of these projects. It's a very good one. And
Thanks. So how did you go from clicking stuff on Disk Detective to becoming one of the science team members on Burst Chaser?
Oh, I just kept at it, and mostly is I ask questions on like done and talk. It's like I think I see this, and then some of the other people that know what they're doing, a lot more experience, and would weigh in on it. And so that's when I get my education of little details that I didn't know, and so I just kept at it. And then after so many classifications, that I got invited to that advanced team. And then when burst chasers come up, because that is my favorite thing is gamma ray burst. You know, I've liked that way back when they were back in the 80s when there was crazy debates over the things. And I was very happy, and I appreciate you helping get that started too, because that has been so cool to me, you know.
So it was pretty much through the bulletin boards on these projects, right? You were started interacting with the other participants and with the science team, just answering questions, asking questions.
Exactly. Because yeah, because I wanted to learn. I was curious, and I wondered about things, and it's neat because there was a lot of feedback with that to help with that, which gave that. I know that there's a little connection with that feedback, and the knowledge from that I was getting was to me very valuable.
So what you're one of the more than 500 NASA citizen scientists who is a published author. Can you tell us about that experience?
Well, I don't know about the published thing at the moment. I am
Weren't
kind
you
of
on
working
a
on.
a conference proceeding?
Oh yeah, when for the catalog, yes.
Yeah.
Yeah,
Yeah.
okay. Yeah. That was really prideful to be a part of that team that is creating the first ever eyeball checking every light curve from the gamma ray bursts from the Swift telescope. So yeah, I watched that, and that was really, to me, kind of a pinnacle. But you know, it's once you get higher, you get to see higher. You know, but so that was neat. And then when you asked me to do the eye poster, and I didn't even know what one was, and I said, sure, I'll do it, just because it's in my nature. But uh, but that was just work. That was just talking a lot with Amy. That was just reading up on things and using a lot of the talk in the comments and on the boards and that type of stuff. And once we got it up to its polished level it's at now, it's really exciting. Now it's looking at adding Fermi soon.
Awesome. Let's
I
dive
don't
into
know if I answered that all the way you wanted, but sorry.
One other thing you all should know about Danny is that he gets the job done. Whatever
Thank you.
task, whatever task be thrown at him, somehow or other, manages to come back complete 7 times over before you know it. Um,
Thank you. That's nice.
Thank you so much, Danny and Mark. I'm going to go ahead and send the mic over to our friend Amy here, who's going to talk about the Burst Chaser project, and we'll bring Danny back on for that as well. But before we do that, for any of you who are expecting to also participate in these projects, since this is very much like a survey over these projects, there's no need to feel pressured to do this right now. However, especially since it's recorded, you'll have the information later. If you would like to receive credit for your participation in these projects, especially getting closer to April, because we'll be aiming for 1 million acts of science participation in citizen science projects. So we would love for you to be connected in this way. You can actually receive credit and track your participation over time by signing up for a SciStarter account and signing up for a Zooniverse account, which is where this project is hosted. So both Burst Chaser and our second project today, Daily Minor Planet, will be using the same platform. And you'll be able to sign up for an account on SciStarter and then an account on Zooniverse to then connect them using your Zooniverse username and adding it to your SciStarter profile. Now, again, there's no rush to do this. You can absolutely do this later. So in the chat, we've dropped the steps there for you. And there's also a lovely group for you to join on Zooniverse so that you can see how everyone else does now and through, well, whenever. The group will last forever. And so we have a special group for all of you. That's the Service Members, Veterans, and Families group on Zooniverse. You can see the impact that you make between now and whenever you check. So I'm going to go ahead and shift the screen over to what Amy would like us to see. So I'm going to go ahead and stop my screen share. And Amy, go for it.
Okay, well, thank you very much for the intro. And I'm sharing my screen now. Can everybody all see it? Let me actually put it on. Yeah, let's go. Good.
Yes.
Okay, great. Thank you. So yeah, thank you very much. Good evening, everyone. Yeah, thanks for the opportunity for me to be here to share with you our project, Birth Chaser. So this is definitely not my own work. So my name is Amy Lian. I'm a faculty at the University of Tampa, and it's actually great to see a lot of people also from Florida. But yeah, this is, as you can see, this is a work from a lot of people, and probably the most important, we have all our NASA volunteers, including Danny, who's really one of the core people that helped build up this project. But we also have students from University of Tampa and a lot of scientists as well, including Mark. So this project, we try to invite a lot of volunteers and try to help us unveil the mysterious origins of gamma ray bursts. So just to start, I'm gonna give you a quick intro of what gamma ray bursts are, because I think not a lot of people usually heard about them. So gamma ray bursts are one of the most powerful explosions in the universe. But don't worry, they won't blind your eyes, because our eyes actually cannot see gamma ray bursts. But if you could see gamma ray bursts, like some of our space telescope, you would see the full sky, like the one that you see on the left here. So you can see there's a very bright spot on top of that image, and it kind of just go boom and then disappear. So within that 10 seconds, that is a gamma ray burst. And within that 10 seconds, you can see that it basically outshines the entire gamma ray sky. That's how bright it is. And on the right here is actually what we call the light curves, which what you see a lot in the Birth Chaser program. So it shows the number of gamma ray photons as a function of time. So what you see is that really the bursts come, it was nothing, and then come, show up, and then disappear again within that 10 seconds. So most of our data are coming from a telescope called the Near-Garrow-Swift Observatory. And this telescope actually has been observing the entire gamma ray sky for the past 20 years, and it has detected over 1,600 gamma ray bursts. And because gamma ray bursts are extremely bright, they really act as beacons throughout the cosmic time and help us understand the whole history of the universe. So now let's first take you to the closest gamma ray burst that we ever detected. And by being closest, what it actually means also is still actually quite far away. It's this gamma ray burst happen at a distance that is 130 million light years away. And what that means is that it took light 130 million years to come to us. So this image, this literally is the image of that gamma ray burst that you see, is not the image of the universe right now, but it's the image of what the universe looked like 130 million years ago. So by studying far away objects like gamma ray bursts in the universe, we are literally able to look back in time in the universe, and we can study the history of the universe. But this is only the closest gamma ray burst. This is actually nowhere near where the majority of the gamma ray bursts happen. So the majority of the gamma ray bursts happen at a distance so far away that it takes light over 10 billion years to come to us. And that's around the time when the peak of the star formation happened. So when we study these gamma ray bursts, we study how stars form, the majority of the star form in the universe. But this is also nowhere near where the furthest gamma ray burst that we ever detected. So now let's take some time to travel to a very far away distance where the most distant gamma ray burst that we ever detected. And it was so far away that it took light over 13 billion years to come to us. So this image that you see is at a time when the universe was only 630 million years old, and it was really just after Big Bang. It's a very, very young stage. So this is a time when astronomers think when the first star were expected to form. So to study gamma ray bursts, we can really kind of put together the history of the entire universe. However, to do that, we really need to have a better understanding of what is the physical origins of this gamma ray burst, or what caused this gamma ray burst. So far, astronomers have roughly grouped gamma ray bursts into two groups. One is called a long gamma ray burst, the figure you see on the left. So you can see when the burst happened, the entire duration is longer than 2 seconds. And astronomers think these are related to supernova. And on the right are what we call the short gamma ray bursts. So when the pulse is actually very, very short, these astronomers think they're related to the merging of neutron stars and black holes. However, this is a very simple picture, and now we know life is much more complicated than that. So here I'm just going to quickly show you a very small sample of all our gamma ray burst light curve. And as you can see, they all come in very different shapes. So in fact, it's actually kind of difficult to directly pinpoint and connect their physical origin just from this plot like this. So what we want to do, we want to build the first pole-shaped catalog to try to help astronomers better connect the gamma ray burst light curve to their physical origins. And what we realized is that humans are much better at recognizing complex patterns than computer. So what we do is actually we invite, at the beginning, just a few dozen NASA volunteers, but now we actually quickly grow, and I'll tell you how much we've been growing so far. But these are the core group that help us build the project. So we launched a project on Zooniverse, which is a popular citizen science platform, last year. So if you actually want to join, here's a QR code too and the link. I'm pretty sure they'll share the link as well. And throughout the last year, we actually have over 3,000 volunteers and over 200,000 classification. We actually completely finished one of the workflow, but we're still collecting more data on the pole shape. So, and all of your vote and classification will come into this summary page that directly used by scientists. So I hope you join us, and thank you very much. Okay, I
Amazing.
think I should stop share. Sorry, this
Oh, that's perfect.
it's always Zoom is a little bit I'm still getting used to. Okay, there you go.
Awesome. We're going to bring up Danny Rowlands again because he is an expert on Burst Chaser, as you saw him in that list of folks who are on the project, and Mark, who's actually going to share his screen to show what it's like to actually participate in the project.
How does this look?
Perfect.
Hey, Danny, I'm gonna pretend like I don't know what all of this is. Will you tell me what I'm looking at here? And I want to do some awesome science. What should I do first?
Well, if you're just trying to learn about it, that learn more is a good start to click on it. And this will tell you the fundamentals of everything that we're doing. If you scroll down it, and it tells you about the spacecraft and the different what the blue parts, just things that might get you a little curious, or you don't, get clear on, such as like this wavelengths, temperature,
Yeah.
that can, and in here also, you can, if you scroll back up to the top, yeah, there's the team if you have any questions or want to send a message to someone or whatever, and you can see the team on the right, so you can send messages or ask questions. And if you go back up to the top again.
So I could just message Amy? Oh, here's her orchid
Well,
info.
that's about her. If you go to her on the side,
Oh, on
Amy
the
Lynn on the
side.
side there, I believe it has the,
Right here.
yeah, that'll give you a Zooniverse message
Yeah.
that you can give on that. Okay.
So say I wanted to get more involved in the project, I could just kind of start messaging with the scientists and with the science team and ask questions and
Probably
just
what's if you go back to the start, and there's a tutorials. If you scroll down a little bit, there's getting started, and this will explain it. This has two optionals to practice, and that way we could, you get a like, yeah, that is right, or no, it's not correct because of these reasons. And
to try this one.
sure.
Okay. Ooh, there's a tutorial. It just pops right up.
Yeah, see now this is the tutorial to go through. And you can read that, classify the pulse shapes and stuff. And this gives you an idea of what noise is. It's always centered around the one line. And the blue is where the gamma ray emission, the computer thinks the gamma ray emission is. And there's the shape. That would be like a fast rise, slow decay, or
Fast rise and then a slow decay. Got it.
yeah. Some people call it like a tell and that kind of stuff. But on our questions for classifications, it's slow decay. So then you can go to the next one.
Oh, okay. Let's go. All right, let me see if I can figure this out on my own. All right.
Hey,
Is
I
this-
think you did where are the pulses? It would
Oh, I
probably
did
be
where are the
more
pulses.
helpful. Why don't you
Okay.
just go to the front again and scroll down a bit and just click on pulse shapes on your far right.
Okay.
There you
Okay.
go. We'll just do a live.
All right.
Okay.
So this is a piece of data from which telescope?
The Niels Grace is the Swift telescope, is what we say in shorthand. So this is in gamma rays. And you see it's rather noisy, but the spike is really easy to see. It goes to a pretty fast rise. It's emitting gamma rays, or the emission of it, for just about 500 seconds almost. It's kind of hard to tell in this one with all the noise, but I would say a pulse followed by extended emission. If you don't know, if you go to your right, all the way to your right, go further. There you go, the field guide.
Oh, that's
Okay.
handy.
There you go. And so if you scroll down here and you see anything that fits what you're thinking it might be, you can click on it and go ahead and click on it, and it'll give examples of what they may look like. And the different shapes.
Yeah, that kind of looks like this, because this distance here, if I just use the x-axis here, here's like 100 seconds. That's like it's almost wider than this one. It's kind of like this one, right? It's
Yeah,
like,
it's got a really long emission for
Okay.
sure.
yeah, kind of like this guy. Just for some
Yeah.
reason, long tail here.
We're just doing the basics here and stuff. So I myself would, what do you I say, what do you think? But it looks like I would just say a pulse followed by extended emission. What
Like,
is that
all
what
right.
seems like to you?
All right.
that'll
And then
take you
what
to-
happens after we select that?
Click next.
Next. Okay.
And
Oh, more info.
see, now it gives you more question, a second tier of questions in that. And it does look like there's a second pulse in there. So you could say one or
More
and
pulses.
it's hard to tell if they're symmetrical or
This
not,
kind of lump
but
here, right?
definitely they're connected by underlying emission.
Maybe we should take a vote. Who
There you
votes
go.
for make some send up little thumbs up or something in the room if you think there's just one pulse. Ready, go. I see a little bit of action. Okay, send up with some noise if you think it's more than one pulse. Okay, I think we have a clear winner. All right, going for more than one pulse. All right, now I have a question. Danny,
Yes.
what happens if we get this wrong? Does that ruin the whole project?
No, it doesn't. That's your viewpoint on it, and statistically, it will average out. And you do want to avoid in science having a bias built into it. That you got to answer what we expect you to answer, type thing. But if you're just simply all wrong, it's not really a big deal. And you can go to done and talk, and put your comment in there. You see that you can see here's where some other people have commented. Yeah, you got multiple pulses there.
Okay.
Mr. Mike, as you
Oh,
scroll
Mr.
down.
Mike thinks it's multiple pulses.
Right. And you can click on down here and you can leave a message or ask a question. if you're unsure of why they selected that when you thought it was going to be something else, and hopefully he'll get back to you or someone will get back to you and explain why they think that way. There's some there I like it.
Okay, I'm gonna add that.
I did want to mention while you were classifying, there is a button that says need help.
Handed, but all
What's
right.
that?
Oh, it's a little heavy-handed now that I've typed it in. It looks a little goofy, but no, I don't think we'll hurt Mr. Mike's feelings.
Just quickly click on classify again. You'll be okay here.
Okay, click on classify again.
Yeah, just to show one aspect of getting help.
Yeah.
There you go.
That's fine. Okay. Oh, we got
You
a new
see
one.
down below the boxes on your right, need some help with this task? Go ahead and click on that.
Okay.
And this will help you with figuring out pulse structures, something close, hopefully, of what you might be looking at. And
Yeah,
then you
a lot
can
of it gets
close
help on
it. Yeah. I
Danny,
just wanted to make sure you knew that was there.
when we're done with this, you and I should like sell cars together, I think.
There you go. Well,
Danny and Mark, this is wonderful. I'm glad we were able to go through one of the examples. There are a couple questions in the Q&A relevant to this project, and we have time for maybe one or two before we talk about the next project. But for those of you who are waiting for questions to be answered, we will come back to them at the end. But there were a couple questions about the process of Burst Chaser. So someone asked, did you say more data sets and tasks will be available on Burst Chaser? Can we still classify images that have a finished banner? How does that work?
well, maybe Amy could speak better to that, but it's not really if you've got if that banner comes up, it means you personally have already looked at it, or it's just finished, completely. So there's no need for it. You could do it for fun, I guess. But
Right. So yeah, thank you, Danny. Actually, that's a great answer. And I guess I was also trying to type in the answer as well, but I think it's faster to just speak. Yes. So currently, right, as you can see, for the post shape, we actually trying to collect for each gamma ray burst. We try to collect, as many votes as possible, right? Because that's going to help us with our statistics. But we also currently, we actually, we've been getting a lot of help on all these, and that's like what Danny mentioned earlier. We do plan to add more gamma ray bursts from a different telescope called Fermi, and we're working on that right now. So, so if you get bored with the current burst, just stay tuned. We'll have more data coming out.
Awesome. There is one other question about satellites where the data is coming from. Do we know how far out the gamma ray satellite is so that it's not blocked by anything else? Like how far out does it have to be? Any other information you can give us about how that works would be great.
Yeah, I think I probably should take that question too. I'm sure Danny now know a lot too. But Swift is actually on what we call the low Earth orbit. So if I remember right, it's roughly, like 500 kilometer, if I remember right. But basically that's, orbiting around the Earth every like 90 minutes. So yes, we actually, Earth, it does block a lot of our view, believe it or not. So, it's like the present that we're here actually does a lot of time we couldn't see half of the sky because Earth is in a way because we're in the low Earth orbit, we're not too far away. But the benefit is actually the name Swift actually come because of reason to observe gamma ray bursts. Gamma ray bursts happen, very quickly. You can see that within that usually 10 seconds, right? Comes and go. So we need usually a very prompt reactions to gather all the information from gamma ray burst. So being on the low Earth orbit make it easier for us to contact the telescope and get all the data promptly. So there's definitely pros and cons. Yeah, the cons is actually a lot of time we don't see half side of the Earth, of the sky. So if there's anything interesting happen there, oh well, we just missed it. But on the other hand, we can gather information faster. So I guess we chose that route. Hopefully that answered your question.
Ooh,
Awesome.
thank
And
you
then
so much, Amy.
Sorry, Mark, go ahead.
Oh, was there another question?
Yeah, if we have 2 seconds, I'm so sorry, I missed one. There was a question about looking at the bursts. Is it possible to make those images stretched out to make the pulse clearer on the screen? Danny, have you been able to find some tricks to be able to find a clearer version of the burst?
Not generally, because the distance is so great, is so far. But there is in the metadata, as you get more advanced, you can use that, and it'll bring up the actual report there. Okay, yeah, there you go, Mark. Thanks. You see the bat light curve there? You can click on that and get all the details there. And on your left, those boxes can tell you like like the slew time, how long it took. Was it slewing into position for missing data or whatnot? See, that's
Right. May I also
and-
add, like, sorry, I know this, yeah, this is great, but do you mind if I add a quick thing? I'm sure Danny's getting to it too. On the right side of this plot is actually you can zoom in. Actually, there's also, the bottom, the right, the second one, yeah, that one. You can actually bracket and zoom in to see more. I know this is not the most human-friendly way to do it. I think this is really good questions and actually a good suggestion. We got this from a lot of our volunteers. So we're currently considering, even maybe we don't have to have people go through this crazy, detailed process. We're thinking to maybe put in a zoom in view on the Zooniverse plot. So maybe we can show like slightly different time scale, like a zoom in version also on top of the overall version that help people see better of the post shape. So we'll give it a try and see whether we can make that a little bit clearer. Because
I
this
was going to
one,
say
sorry, go ahead.
say one thing. Mark, if you scroll up a little bit and to the image, just scroll up. There you go. That gives you a rapid view of how much noise is compared to the signal for things. And so that's like what the image would be for the gamma ray sky.
Nice. Well, with that, thank you so much, Amy and Danny. We are going to move from the high redshift universe, as they say, to the very low redshift universe. We're going to journey from the other side of the universe right to our own backyard, our solar system, and take a look at a project called Daily Minor Planet. And I bring you Carson Fulls.
Hey, everybody. Thank you so much for having me here. Let me bring up just a few quick slides we can talk about. And I'll tell you all about what we do at the Daily Minor Planet. All right. Next slide. There we go. All right. What do we do there? The Daily Minor Planet is the volunteer science project that we developed here at the Catalina Sky Survey. I'm out in Tucson, Arizona at the University of Arizona. And the Daily Minor Planet is really just an extension. It's the exact same work that we do at CSS. What do we do at CSS? We're a NASA-funded planetary defense project. We do planetary defense all day, every day. That's it. Our mission, straight from NASA, is to discover and track near-Earth objects. That's all we do. What are those, and why should we care about them? So I say NEOs a lot. They are mostly asteroids. You call those NEAs, but there's about 122 comets with orbits that bring them close to Earth. And, close in terms of space may not be close in terms of what normal folks think about, but anything that comes closer than 28 million miles, we consider a near-Earth object. Currently, there's more than 37,000 known near-Earth asteroids, and we are finding more of them all the time at the pace of about 3,000 a year. But we're still not done yet. There's still tens of thousands that need to be discovered. Why do we care about these rocks out in space? Well, because they can impact the Earth. That's the defense part of it. So I'll give you a little rundown of what we do at CSS, because what volunteers do at the Daily Minor Planet, it is exactly the same. In fact, when we were putting together the Daily Minor Planet, the goal was, well, we can't hire everyone to work at the Catalina Sky Survey, but we really want to share what we do with the world, because I think lots of folks could contribute. And this is our way of doing it. So let me give you a rundown of the process, and then I'll show you some data. So it's fairly straightforward, not a lot of fancy stuff going on. We have our telescope up in the Catalinas north of Tucson. It's not a terribly large telescope. It's only a 1.5 meter. But that telescope has a camera on it, and we take 4 images of the exact same part of the sky. Okay, and they're about 6. Each of those images about 6 minutes apart. Then we do some processing on those images, and we basically blink them, or you can think of that as animating them like you would a cartoon. So we blink them back and forth really quick. We use our computers to kind of help identify anything that might be moving around in those images. That's because stars that take up most of the image are just going to be in the exact same spot, image to image. But asteroids move a little bit between each image, and we want to pick those out. We do a lot of computer work to do it, but we let the final decision rest with a person. So we have actual observers on top of the mountain with the telescope, actually looking at this data in real time. It takes about 10 minutes from the last photon hitting our telescope until a person is actually reviewing the candidates that were picked out in this image. Why? Aren't computers smart enough? Well, computer could probably do, as Mark said, about 95% of this, but that last 5% is still critical for us. False detections, us thinking there's an object there when it's not really, are bad. That creates extra work for people to go check because it's important. It may be on a path to collide with Earth. But also missing objects is bad too. So we aim for perfection. We don't want to miss that next object that might come very close or impact the Earth. We submit these observations of newly identified objects as soon as the person finds them to the Minor Planet Center. They're based over at Harvard. And then we keep tracking these asteroids night to night. So the daily minor planet really comes in directly after this. So our project, you won't generally be waiting for data because every night we run the telescope. In the morning, we send the images down to our lab on campus, and then we start uploading them to the Daily Minor Planet. Every night we get data, the project gets data. Our observers up there on the mountain only have a finite amount of time and bandwidth in their brain to review these images, and they get through quite a bit, average about 4,000 candidates per night. But there's still more that we don't have a chance to review. We just don't have the time. So we take about 4,000 more candidates, and we upload those to the Daily Minor Planet for volunteers to look at. And we can get pretty good with the first 4,000, but there's still discoveries to be made in the next that we upload to the project. Let me give you some examples of what these look like, and hopefully you'll see what we're trying to get folks to identify in these images. All right, so these are going to be near-Earth objects that were discovered with the Daily Minor Planet. So these were missed in our normal processing, or they weren't reviewed in our normal processing up on the mountain, but they were picked out by volunteers. So here's the first one. And you can kind of see what I was talking about. There's a sequence of 4 images on the project. We're going to highlight what we want you to check out, right? And it's that streak that goes straight up through the center of the image, right? And you may see, oh, hey, there's another little guy over there. Yeah, there are asteroids everywhere, and we keep loving to find them. There's one. Let's see if we got another one. Yep, there's another one going straight across the field. These objects are streaks because they're moving pretty quick. And so as they move, they cover more and more pixels in our camera. So they're not nice single point sources. They're kind of streaked out. NEOs tend to have that kind of motion. Let's see if we got a couple more. There's another one. This one had a little fainter, a little harder to pick out. Kind of gets close to some stars. Maybe that's why the computer had a little bit of issue with it. But humans are really good at picking out motion, and we take advantage of that with the project. We've got maybe 1 or 2 more. This one was a tough one. That one's actually quite faint up there at the top, but our volunteers were able to identify it. And one more, this one's not moving quite as fast. You can see the stars are kind of bouncing around a little bit. Maybe there was some wind that night. The seeing wasn't that great, but our volunteers still came through and picked this out of the subjects we presented with them. Oh, I could just go on all night looking at these. There's another slower moving one. We're really close to those stars. All right. Well, that was it for the slides. I just want to give you all a brief overview of the project. I know Mark's going to jump on and try to wind his way through the actual project online, but it helps to know where the data is coming from, how we get it, and what we do up on the mountain.
Hey, Carson, do you think we might be able to discover a new asteroid in real time here together?
I always hope for it, but you know, I don't control the data, but we will have to see.
So what do I do first?
All right, so first you need to sign up for an account on Zooniverse and head to the Daily Minor Planet there. You can get to it through NASA's website, through searching on the Zooniverse. Any way you can find it, it's the Daily Minor Planet. But it should dump you eventually onto our homepage here. And you can see there's a drop down up there, Explore the Project. You can take a look at that first and see what we got. Yeah, so if you're new to the project, you can check the About and learn. It's basically what I just told you all about asteroids, all about near-Earth asteroids. And I think if you scroll up there and you do the other drop down under About, oh, right in the middle. Oh, there you go. You can see the team. There's a bunch of us working on this, folks who work at CSS, and we have a lot of volunteer moderators and translators who just put their hand up in the community, said, I want to help out more. What can I do? We have quite a few different languages available to folks as well to increase access to the project, because we want everyone who can to help out. One more on the drop down, if you can go to that, would be the results, because that's what we're most proud of. The results. So are we effective? Oh yeah, we are. We have sent in observations of almost 3,700 main belt asteroids, and we've sent in observations of nearly 100 near-Earth asteroids. And if you scroll down a little bit, you can review every single one of those that we have found. You click on the subject, that'll take you straight to it, and you can see what that real object looked like. And if you're starting out on the project, I try to direct people towards this where they can kind of get a feel for what is a real object. The best thing to go for is examples. And well, there's 3,800 examples.
Okay, I'm drooling. I want to go discover something. How do I do it?
Okay, if you want to get started, then you have to go down there to the validation bar, and that'll take you.
Has
Perfect.
anyone ever seen this image before, or this little video?
So possibly, we do upload data every day. Every night that the telescope works, the next day you get the data fresh, hot off the presses. And after about 5 days, we retire it to get new data. But this one, I don't know. Maybe someone has, maybe someone hasn't.
But it's possible that nobody's ever seen this before.
It's certainly possible. I don't know. What do y'all think? We can do the same thing Mark did. If you think it's real, put a reaction there, thumbs up or party time, whatever you want.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
I see a lot. I gotta agree with folks. I think that's a real one.
This
Right.
is beginner's luck.
Beginner's luck, maybe.
And
All right.
again, what if we're wrong? What if we're like, it looks real, but
So that's the beauty of doing this together as a community. If you get something wrong, that's okay. We don't depend on just one person. We take the votes of at least 7 or 8, up to 15 people before we finally make a decision whether something is real or not. So if you mess up, that is okay. It's part of the learning process. And you're depending on the rest of your team to come together and make that decision. But the task is simple. It's yes or no. Is it real or not?
I'm hitting yes. I'm doing it.
All right.
All right, should I
Then
just
you,
move on to the next? Let's just do another one real quick. In case
yeah.
Oh, hey,
Oh,
what
hey.
happened here?
So we do take so many images of known asteroids that we inject them into the project. And we do that for two reasons. One of them is to give you feedback in real time. So yes, you got that one right. And it tells you what the asteroid is. All right. Second one is actual real discoveries of unknown objects are pretty rare. So if we had you just say no, 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 you kind of zone out and you stop thinking. And so this re-engages you. So it
Okay.
has those dual roles. So hey, we were right though. We got that one right. That's 2012 YW1.
All right, let's
All
do
right.
another one. Another one. Come on.
Okay.
All right, make some noise if you think this is real object. This is a tougher one.
It is tougher. What you're seeing, that black bar on the side is the actual edge of the image.
Ooh.
Ooh, who thinks
Let me-
this isn't real? Oh, I see a couple more.
Lots of
I
tomatoes being thrown at the screen.
I think we got to go with no for this one.
Can we get any more information about this thing? Can we like manipulate this somehow, or what's
You
this?
you you can. So that shows you the individual images. If you click that, you can click it again down there at the bottom left to go back to the to the video screen. The one thing that people like is that one. That
Yeah.
inverts the colors. Some people really like to have them inverted. It helps them pick out objects, but it's your preference. You can also zoom in, zoom out. You can technically rotate it. That may help some folks. That option's there for you, but the inverting the image definitely can help sometimes. A tricky one. Zooming in and zooming out can also help. You can also go to that number one down on the bottom, and you can speed it up or slow it down if that's too slow or too fast for you. Everyone kind of has their preference of some people like it really fast, some people like it slower. It's whatever works for you.
Yeah, you can see why the algorithm got confused here. It looks like there's a galaxy next to a star, maybe even a variable galaxy or something.
Absolutely. It really loves to latch on to background stars and galaxies. And you will see some of the most beautiful galaxies in these images. It's just nice to take a tour of the sky.
All right, we voted this one off the island. I'm kicking it to the curb. Hasta la vista, baby. One more. Can we do it? I'm slowing it down a little bit.
I don't know, what do you think? You want some pointers, stuff that I look for in these?
Yeah.
Okay. So I kind of put my mouse where that first circle is and I leave it there. I say, okay, I don't see anything there when the circle's there, and then there's nothing there when it moves. Okay. But for the second one, if I put my mouse there and look at it, I think it's really just latching onto that star kind of wobbling around.
Yeah, I see what you mean.
Yeah, so that makes me think, no, this one's not real. That third one, I can maybe see a little dot that comes about in the third image. Maybe the fourth one too, but that background star I think is making me lean towards no.
Right.
And
Carson,
oh, go ahead.
anything else we should know about this project? Any other tips, like why is this called the Daily Minor Planet?
It's called the Daily Minor Planet because we upload fresh data every day. And because we're trying to be like Superman and saving the world.
Yeah.
All right. Two other things I'll tell you. If you're not sure about one, that's what the done and talk is for. You know, odds are, if you're not sure, it's more than likely a no because only about less than 1% of these are real objects. But if you're not sure, and you're just kind of leaning on it, you could say no and then go into the comments and say, hey, I'm not real sure about this one. What does everyone else think? And it's a good place to discuss, talk with folks who've been doing this a long time, and get their input. And the moderators on our project are really, really awesome folks. And they will get to you and discuss it. Perfect.
Awesome. Carson, what a cool project. Thank you for helping keep us all safe. And now I get to introduce Sarah, who is my right-hand person leading the NASA Citizen Science portfolio together with me. Sarah is going to tell us about, actually, Sarah's going to introduce some more of our citizen science projects. Go for it, Sarah.
Thanks, Mark. It's a real pleasure to be with you and with everybody else here tonight. So I have the impossible task of telling you about all the other projects that NASA offers. I'm not going to go through all, I think we have 36 of them now. I'm not going to go through them one by one because I don't think that would be interesting even for me, and I love these projects. But I'm going to tell you about some of the groups of projects just to get you interested in looking around to find the project that's right for you. So you've heard about 2 of NASA's projects. They each have, as I said, there's 3 They each have their own topic area, their own research area from way outer space to right here on Earth. They have their own personality, which is really created by the science team, but also by the people who are participating. Some require your full attention. Others are great to do while you're waiting in line or waiting at the bus stop, whatever you're doing. But you know that if you're doing a NASA-sponsored citizen science project, your time is not going to be wasted. You are doing something with a purpose, doing something that can't be done without the effort of you and lots of other people, and you're doing it in search of new knowledge, which is really exciting. So the first kind of project, these are the projects that you've heard about already tonight. They have you classifying data. That data is represented to you in some kind of an image. It might look a lot like a picture, like in the upper left or the lower right or the lower left, but it might look a lot more like a graph of data. So you can choose what kind of project, what kind of data you want to look at. And these all do happen on your computer, wherever you are with your computer. The next kind of project takes you outside. So there are a bunch of projects that are asking you, inviting you to make reports and observations from wherever you are around the world. These typically require a smartphone, and nothing more than that. Sometimes these projects are what I call a feeding 2 birds with 1 scone project, and that they have an immediate value where you are. So the Mosquito Habitat Mapper project, which you see, those are all wriggling mosquito larvae. They teach you how to identify where mosquitoes might be breeding in your neighborhood or your community and how to disrupt that breeding site. But they also are collecting information for scientists who are looking at the global distribution of mosquitoes. And with the mosquitoes, you probably know, there's a lot of diseases that get carried. So it's a real public health, global public health project, but you also have a real value right at home where you are. The third group of projects are projects that require something special. It might be that you need to have some special equipment. You might need to have some special skill. You might need to be somewhere specific. So pictures here represent the Aurora Source project, which is looking at the energy coming out of the sun, space weather, and looking at how it excites the atmosphere and how we see auroras. You have to be in high latitudes or the low latitudes for that. Same for Fjord Fido. The project kind of in the middle and the bottom is Exoplanet Watch. So this is a project for folks who have telescopes. They get involved in collecting observations of distant stars, looking for that telltale dip in light that might indicate that there's a planet orbiting that distant star. And on the left, These things are amazing. That's a transient luminous event. These are really fast, really rare. And it turns out there's already a huge community of people who have been observing these and learned how to take photographs. And scientists are collaborating with them to study these really unusual things that happen above storm clouds. The final kind of project is one that involves experiments. So in the upper left here, you actually see two astronauts on the International Space Station eating a plant that they grew. That plant might have been one of the plants that was identified by the middle school students or high school students who are partnering in Growing Beyond Earth. They are helping NASA figure out what are the best species of, like the best varieties of plants to grow to support the health and well-being and literally to feed the astronauts of the future on long-term space travel. There's also a project that's called Ham-Sci, which stands for Ham Radio Science Citizen Investigations. This is a community of ham radio, amateur radio enthusiasts who get together both to communicate around the world, but also to share information about how their signals are traveling, which helps scientists answer questions about our ionosphere. And they actually work with the scientists to pose the questions and then actually do the whole investigation and answer it. So there's lots of different modes of projects and all these different topics. So I have some, Emma, I think there are some, I have a tip for you for visiting the NASA Citizen Science landing page website. When you go there, you're going to see a grid of images of all the different projects. And underneath, there's a little read project summary link. Those project summaries can help you quickly get the information you need to evaluate whether a project is of interest to you. It'll tell you in general what science field is being addressed. Is it inside or outside? Do you need any special equipment? What's the research question that's being asked? And is it something that's of interest to you? With 36 projects, we have a bunch more in development. Some of the projects that are live today will complete. They're going to answer their question and the science teams move on. So there's a steady kind of churn of projects. And we really hope that you find the project that's right for you. You may have to try a couple out to get the one that really sings to you, but we hope you stick with it. And we have a few more opportunities that you have to work with us to help ask questions and let us help you find the project that's right for you. And we'll tell you about those in a minute. But now I'm going to introduce my friend and colleague, Clarence Bostic. Clarence is the Deputy Program Manager for Science Activation, which is a NASA program that helps bring NASA science and people into classrooms and museums and other learning opportunities for people, learners of all ages. While Clarence has not been a service member himself, he was a teacher at the Yokosuka Naval Base in Japan. And in his words, that's where he fell in love with the military community. So he's lived with you, he's taught your children, he knows something about you, and he's here to share some opportunities that NASA has specifically for service members and their families. Take it away, Clarence.
Thank you so much, Sarah. I really appreciate you. And thank you so much, everyone, for having me tonight. I am Clarence Bostic, and I'm super excited to support this community of learners. And I'm here to talk a little bit about connections between NASA, service members, veterans, and their families. And whenever we think about that, when you think about doing something with purpose that Kim and Danny talked about, or doing something bigger, those things can be in your family, they could be something in your career, or they could be a hobby or a skill that you learn. Because really, hobbies are ways that you help to learn and practice new skills. And so these hobbies that you actually pick up actually can help with mental health, helping to increase that neuroplasticity that Danny talked about a little bit earlier. And so that's one of the great connections. And so when we talk about benefits of engagement, one way to get engaged and stay connected is by actually starting to look at things that are, if you're in the military, you can actually go to the Military One Source and look at the Mil Life Guide for NASA Science. And so the Mil Life Guide for NASA Science actually has bunches of different opportunities that are available that we've kind of tried to create a kind of a curated list that people could enjoy, whether they're living on base, off base, and all over the world. So this includes things like Science for Everyone, resources for formal and informal educators, STEM for all ages, lesson collections if you have homeschool students, art projects, NASA science events, these things that are going to be happening all over the world and everyone will be able to enjoy at the same time. The other things you can do there, of course, are you can actually get connected to our science.nasa.gov website, and you can see the full gamut of the opportunities, the research, the missions, the things that we're doing with NASA Science. And so we also would welcome you to visit us there. In terms of other ways to get engaged, we actually do have NASA jobs. While there is a freeze right now in the NASA hiring, typically NASA civil servant jobs are found at usajobs.gov, and you can type in the word NASA in the search area, and it'll give you all of the NASA positions that are available. Also, we have NASA Skill Bridge. So if you're a military member coming towards the end of your time of service, you actually can join Skill Bridge, and Skill Bridge is for military members ending their time in uniform, and it offers a chance for you to serve as a NASA fellow during your last 180 days of service. And so that's a great opportunity also to work with NASA as a Skill Bridge fellow. We also have NASA internships. The NASA internships are great for those people that are, they either have a student that's age 16 or older, or they may have may be in university themselves. And so this is another great opportunity as well, going out to intern.nasa.gov. And there are lots of different paid internships for US citizens. And in addition to those opportunities for US citizens, if you go out to JPL, there are also international internships that are available as well. For military base resources, we're starting to have a new relationship that we've started to build with the Military Family and Community Policy. And we're really excited about this new relationship because in addition to the Military One Source, which is actually an outgrowth of the MCF&P opportunity and the relationship we're trying to build, we also have a great opportunity to work with each base and doing different things. Some bases have 4-H clubs, and so some of those bases are already working with NASA Science, whether it is offering STEM ideas or working as part of various SciAct teams that have science activation teams that are working to support 4-H through GLOBE projects or through NASA centers or through NASA developed ebooks. We also have military partnerships through 4-H. And also we have another science activation program project called AstroCamp that's also supporting 4-H programs all over in all of the bases that are associated with 4-H that are interested, as well as we have a brand new cohort of folks that are getting involved with AstroCamp that are in military communities. And so some base after school programs have started to do a pilot program with NASA AstroCamp. And so please be on the lookout for that if you're living on a base or closely associated with a base. Those bases have folks that are working in their after school youth development groups that have decided to volunteer their times and to raise their hand and say, hey, I want to learn this skill and I want to find a way to work more closely with NASA Science through NASA AstroCamps. Also, you don't even have to wait for NASA AstroCamp. Let's say, hey, you're a military member. Hey, you're a person who might be a military spouse. Hey, you're a veteran. You don't have to just wait for all the kids to have all the fun. Yes, you can always get involved with citizen science, which is a lot of fun, a lot of great ways to always get connected. Also, there are other great opportunities that you can find at science.nasa.gov that are available there. You can also find it doing citizen science. You can do those things with your family member. Because your military member may not have to be in the same place, you actually could still do the science together. And it could be something that you do together that you share. You could even do that, whether they're actually in uniform, out of uniform, working together as a family. When you're going on family hikes, when you're doing things during outdoor recreation activities. There's always a great opportunity to do sky watching, and there are sky watching guides that are actually available for free, of course, at science.nasa.gov. All of these are great opportunities and ways that we're hoping to, again, develop connections between NASA, service members, veterans, and their families. Lastly, can't forget the military bases. Please visit your base libraries. Those base librarians have already started reaching out to find ways that they can also start to incorporate NASA science into their resources and to make sure that their communities have the best and brightest NASA resources available. So I want to thank you so much for your time, and I'll turn it back over to Emma.
Amazing. Thank you so much, Clarence. That was all really awesome information and so much packed onto one slide. For anyone who is thinking, oh my gosh, how do I keep all my thoughts together with this and make sure I know everything? We will include all the links and a reference to this slide in the follow-up email. So not to worry about any memorization, that is not needed. So we know it's a lot. Which, speaking of it being a lot, be aware that we're closing this meeting in 8 minutes. And so if you have questions still unanswered in the chat or the Q&A, we're doing our best to go through and see if we can answer some directly. But on the next slide, I'm actually going to share with you one last Menti poll, just to ask what you want to hear more about. We know we packed a lot into this one. And so if you have thoughts on what would be the most impactful to you and the most useful to spend some more time on, we would love to continue this conversation. And I will follow up with a couple other slides about what's happening next, because this is not the last time we hope to have you hear from us. And so essentially, if you have thoughts on, oh, I'd like more time to do to participate in one of the projects. Oh, I would like to hear more about veteran and military family resources through NASA. All of those thoughts, if you want to put them in the chat too, that is all good. And Mark just added to the chat, we're just getting started, and it can't be said any other better way. So that's amazing. Yes. Awesome. All right, I'm going to give you a couple moments while you look at that, and I will talk through what is happening next in the meantime. So we do want this to be a start of a conversation. So in April, in a couple of months now, we want to invite you all back to join us for an event where we will be doing more participation and coming back together to try to do as much citizen science through projects as we can in order to reach our goal of 1 million acts of science for the entire month of April. And so I'll talk a little bit more about that and define that. But while we have some items going into the Menti, I'm going to go ahead and look at those a little bit. So what would we want to hear more about? What would you like us to focus more on? I see family participation in projects, absolutely. Clarence, you actually had an amazing thought in terms of the younger ages, and so I wrote that down so I could repeat it back to y'all. But for any of you with small kids, you can also visit science.nasa.gov/learn, and I'll go ahead and drop that in the chat too so you can see it, because that website will help you with especially the younger folks. And then we also have ideas of plant growth for food sources. Sure. I think having a social event where people share their why of doing citizen science. I love that. Yeah, Danny, we loved hearing from you, so that's amazing. Careers and opportunities with NASA, gamma ray bursts, and their various aspects in more detail. Yeah, so having more time to talk through the projects, that's all wonderful. Okay, and we will look through these in regards to how we plan out our April event too. And this is a start of a conversation. So a while back ago, we mentioned that we have a process for being able to track your participation if you would like to, but it also includes a group that's on Zooniverse. We had one question come through on like making sure we could join the group. I'm going to go ahead and Roland will actually pull that list of steps if you would like to be a part of that process of tracking participation up from now until April and checking in on that. It's basically a leaderboard, so you can see how wonderfully you do over the next few months, and then we'll come back together. Now, because this is the start of a conversation, we also want you to recognize what the importance is of all this. And so what's important is really what's important to you too. And so we wanted to share a thought from a SciStarter user where someone mentioned sometimes the world feels like it's spinning out of control, where actions can appear insignificant and change seems out of reach. Citizen science gave this person hope, a sense of possibility, and gave purpose. And so if you find any of those things in our conversation today or your participation in the future, we very much value that. And we very much look forward to seeing you again in April for 1 Million Acts of Science. We want to build a community of you all, so it'll be all hands on deck when we get back to talking to y'all in April and having another event like this. If you apply or if you registered for this event, it's likely that you also saw April 10th. We'll include the registration link in the follow-up email to you as well, so that you can go in and sign up to join us again. If you are looking for instructions on how to do all this in the meantime, I'm also going to drop in the chat the NASA Live web page on SciStarter, which has all the information. Oh, and was just dropped again by Roland. Thank you. Stay involved, find more NASA projects and recordings of our events, including this one, but we'll also put it in the follow-up email. Now, we're low on time, so unfortunately we won't get to all of your questions, but there is time for us to be able to answer them independently in the Q&A, and we will get back to you in April, hopefully with more questions if there were bigger ideas we want to get to. I want to take a moment to thank all of our speakers. There were so many of you. I'm going to go ahead and ask you to turn your cameras back on and unspotlight myself. You all are amazing. Thank you so much for joining us and having this time with us to actually share what you do, because you do amazing things. And we're so glad to actually be able to talk to you. So thank you all, and thank you for everyone who ask questions and answer questions from our folks who are speakers to talk to us and engage. Mark, do you want to share any final thoughts?
Thank you, Emma, and all the folks at SciStarter. Emma, I know this has been a big project for you, and it's just really fun working with you guys.
Thank you. Amazing. Awesome. And I see a lot of thank yous coming in from the chat. So thank you all for being our guests. We really appreciate you. We do it for you. So please keep coming back and enjoying us and having conversations with us in a big way here. Amazing.